Welcome to this session. I hope you enjoy the conference and you have a great time up until now, and you will definitely do until tomorrow. Today I'm going to cover database design, but the modern part of it, whatever that means. So I'm Maggie Nomova, and I'm a founder of two consulting companies working in Bulgaria and in Norway. I live in Oslo, and probably one of the best countries to be locked in for 2 years during the pandemic. But anyway, I'm happy to be here today with you. And during my experience of being consultant, trainer, and speaker, I've seen many cases where the database are not so modern, but on the other words, they become like old-fashioned, and that prevents the scalability and potentially even availability of the database, not mentioning performance. So that's why I am here today, because I want to share my experience and I want to give you some insights of what could prevent your database from being modernized, in other words, being scalable and performant. I have more than 20 years of SQL Server experience, starting with SQL Server 6.5. Oh, that's many years. So. Anyway, I don't want to remember that time, but now I'm still enjoying the new SQL Server versions. Despite all those years, I'm so excited we had a new version coming in SQL, and we will enjoy even more features of it. I hope you had a great time yesterday in the keynote, so I will mention some of the features that are coming and how they make your database modern. I'm Microsoft Certified Master in SQL Server. I worked for Microsoft for 6 years in Microsoft Consulting Services, which were a great time in my career. I'm an Azure Data Engineer, MCT, and because I love speaking, I guess I'm an MVP for 10 years already. So let's start. What does it mean to be modern in a database space anyways? So my understanding is first of all, your database is modern when it responds to the data volume, to the more and more requirements that are coming from the business and from the sponsors. As business grows, it has to stay flexible and it has to respond to those requirements. So that's data volume on the first place. I couldn't remember, even several years ago, to talk about petabytes of data. Now we talk about that even in the data warehouse, but in the operational databases, we talk about completely different sizes already. Data variance. We have to process and store data from many different data sources. That means social networks, that means whatever you may think of. And our database should be part of that. So that means we need to store more data types, which for many cases is a little bit an issue or becomes an issue. So I'll talk about that. And last but not least, real-time analytics and availability. So in these days, real-time analysis or being able to respond immediately to the business insight, to the business request is extremely important. I hope you will not argue about 24/7 availability. So I tried to argue several years ago when the business said, well, okay, when I asked, do we have a maintenance window? And I said, no, we don't accept a maintenance window. We have to have our database 24/7. And then I tried to respond with a design like this. For example, you need 4 servers at least. You need 2 data centers. On all those 4 or 5 servers, you need SQL Server Enterprise Edition, and that will cost you some stuff. So I managed to agreed on some database maintenance window at that time, but today, nowadays, it's a little bit more difficult to convince your business that no, maintenance is not like I need maintenance and I can't afford to have my database 24/7. So we need to find a way to do that in order for a business to respond to the trends. So all that stuff comes as a business requirements. From the other hand, we have trends. So those are all those buzzwords that you hear all the time, like cloud, big data, NoSQL, microservices, JSON, blockchain. So pick one. And at some point they come, or even though we try to like stay away from that at the back end, they come, and we are like eager to embrace that at some point. But what is this about? Well, modern means change. Why should we change something that works, especially at the database level? Well, we could do that because we want to achieve a better scalability, a better performance, and offer a cheaper service, a better availability. So it's not about changing what we provide to our database, from our database to our users. So they will probably receive the same queries, but how that will cost, and will we be able to provide all those requirements to them? So in this session, as I mentioned, I'm going to share my point of view and some tips and tricks from my experience, how the database could go modern, at least from the performance scalability point, and what anti-patterns you could potentially try to avoid or redesign in your database or change in your database in order to get like that scalability that is needed by the business. Well, modern database does not necessarily means cloud database though. So those two could be completely different. I started a performance tuning project several months ago, and with one of our clients. The first challenge was to deal with performance issues. They had an extremely bad performance parameter sniffing issues in their SOAR procedures due to extremely bad where clause with the or inside the where clause. So that makes a lot of troubles in the code. But after we managed to isolate the performance problems, they started thinking about going to Azure or migrate to Azure. So you never know. They actually had this tenant design. They had many databases responding to for covering many customers of theirs, and that was like a really good candidate as an architecture to bring into the cloud. So, but it's not necessary to be the cloud database though. So we could potentially think of a modern database as a database which could embrace those patterns that already exist in the cloud, like scalability, extremely good scalability, actually, good flexibility, easy of maintenance, responding to changes quickly. So those things matter, and this is the important part of being modern in our database layer. So what modern means and how the database should respond to that, what are the essential things that we should consider when we talk about modernizing? Wow, that's a fun. So first of all, we have to start with a small transaction. So basically what I've noticed is, as complex the code is from the transactional perspective, it's hardest to troubleshoot. It's harder to troubleshoot, harder to redesign, and harder to scale. So if you have a really big blocking issues, really tough blocking issues and problems, then potentially that could mean transactions are like long. You have probably user interface input during the transaction, which is bad. That should potentially be in the scope of change. According to the retry logic, well, every single application which connects to the database should embrace that and should have that. I noticed that Bob Ward had mentioned that yesterday in his presentation, how from the application perspective you could build a retry logic in the database. So there are many ways to do so, and in new .NET framework you have a specific method for that, so it's good to try. But anyway, we should not rely 100% of on network reliability. So the networks stops responding, or they break, or they interrupt. So we have to protect our database, especially if there is a transaction, if it's happened in the middle of transaction. So retry logic is absolutely necessary from the availability perspective as well. So no matter if you work in the cloud, or if you have your database in on-premises environment, you will face issues like this. For example, if you perform a failover, or if failover happens, your application needs to be able to reconnect and retry. So I will say that a stateless logic, when it's presented in the database, it's something that will prevent not just migration to the cloud, not just a label of modern to the database, but any change further, even migration, or even like consolidation of the databases at the enterprise level, in the on-premises environment. So I would say that stateless logic means a little bit more than just a single comment, or just saving transient data like sessions or any other data in the database. It's like doing an iteration using cursors. Well, fewer cursors here is like just politely to say. I would say no cursors at all, for God's sake. So SQL Server has never been a good engine for running an iteration logic. On top of that, what I've noticed is we have a lot of like chatty applications. Chatty application means, for example, you send a lot of comments like queries all the time, and you perform connect, run a query, then disconnect, then connect, run a query, then disconnect, and that happens like in a loop, multi-time per second, and that will be extremely chatty to the database. I had an experience like this with one of our one of our clients. They tried to migrate to Azure. They have several databases, but yeah, it happens that they ended up with issues. Actually, they tried to leave the application on premises and migrate the databases in the cloud. That was really weird. But what they realized, the good thing of it, was that they realized that their data access layer is really chatty. So they try to enclose at least those stuff in the batches to reduce the comments that they sent to the database, to potentially use connection pooling for similar connection strings. So note that if the connection string differs, then you could potentially end up with the connection pool fragmentation. So we have to find a balance there as well. And what they managed to do is we managed to end up together with good design, and to improve at least that part, to make the application less chatty to the database by enclosing at least some of the statement in batches, and running them in store procedures as well, instead of like sending ad hoc statements. Well, when it comes to a modern database, we have to embrace, we have to align with this constant tuning that we do all the time. It's not just we tune our database and then we do something like when the problem comes. It's very important to plan for that tuning. And it's like running an expensive query analysis. You can use a query store. Query store becomes really good option. They improve that with every single version of SQL Server and in Azure. So the other option is sometimes we prefer to recommend to a customer, especially enterprise level customers, we prefer to recommend a specific tool dedicated for SQL Server monitoring. When do I do that? Well, when we have to be able to track, we have to be able to compare baselines, like, for example, on a periodic basis. Or we have to be able to track what happened and how the blocking, or what the reason behind blocking, and why the blocking occurred yesterday. So currently, SQL Server doesn't have anything like this out of the box. So Query Store could be extremely useful for you if you want to find out your expensive queries. But if you want to track those problems, then you potentially could plan to make an investment in a specific tool for monitoring SQL Server performance. It's important to monitor and to tune when we have a regular workload in order to scale up further when the time comes, because you never know. So you know that some of the services, even in Azure, they were extremely overloaded, and they should respond extremely fast from the scalability perspective at the beginning of pandemic. So you know that at any time, that scalability should be needed. Should I do index tuning all the time? Well, when somebody asks me a question like this, I always remember one of my cases when I troubleshoot a migration to a different environment in an enterprise SQL servers, and it happens that they had serious issues on waiting on the write lock. So that's because they migrate to a different hardware. But one of the problems was that they had extremely bad over-indexing. And they had a lot of transactions. Like during the transaction peaks, over-indexes means you generate an extremely big transaction log, which has to go through the secondary replica. So if you have an over-indexing in your transactional database, that potentially will generate a lot of IOs. If you migrate to the cloud, those IOs you will pay for every single one of them. So that's not a good stage to be in. In that case, when I mentioned that they potentially could reassess their indexing strategy, and the response was like, "Oh, come on," from the DBA. So he said, I did those indexes, every single one of them, and it took me 10 years. I'm not removing any one of them. So I was like, okay, but see, you have those, probably we can try, and if we can try that, and if that happens better from the performance perspective and reduces the write lock, we could do more. So you can see those indexes which haven't been used for months. So that's always something that is like a balance that we have to achieve, and that should go all the time. It's not something that you stop and you'll do after a year, because the database changes and the data changes. Auto-tuning of indexes in the cloud is a good option. I will start with it, despite I actually want to have control over everything, so I'm not trustful of those wizards. But anyway, that's a really good start for tuning. So let me dive a little bit of a specific patterns that I've selected, which prevents scalability and good performance of the database. So first of all, row by agonizing row. This is not just row by row, as you may see. It has an extra A there. because it's about a database, and because it's that in the database, that pattern is even more harmful than in every other system, because the database is a set-based system. It's not something that you can play with, like iterating through. So I mentioned cursors, but there are more than that. So you can say, yeah, I'm not using cursors actually. So, but other statements also could generate or bar pattern. So that pattern we should avoid. Which are those statements? Well, for example, a very complex correlated subqueries. They could iterate through the row set many times for every single row of an outer query. And that could potentially run extremely bad with consuming very much resources of the system. So some functions which we run for every single row could also harm and go to our bar. What I've seen in these cases, they really harm, and those you cannot see as a bad practice and as an effect of performance issue while you perform a development. So in the development and testing environment, they work pretty fine. Basically, they create problems when you transfer your code to production, because you have different rows there and because you have different statistics, and basically all the execution plans are different. So in that case, we better embrace a set-based logic. So potentially every single cursor, I would say, except probably some that administrators use, they could be rewritten as a set-based logic. We could use CTE, common table expression. Well, CTE and derived table is a good alternative of really complex correlated subqueries, and they would potentially overperform those subcorrelated subqueries. Sometimes I see a data type as something that could perform better. How? How many of you have a table type with a TVP, table valued parameter? Are you familiar with table valued parameter in SQL? How many of you have used table valued parameters? Good. So then you know, let me show you then what do I mean. So when it comes to table type, this is something that you can use in SQL in order to transfer a set of values as a parameter to a store procedure. So you can create a type at the database level, and it has a structure of a table. Then you can potentially assign or insert values in it. So that makes it a table in a different scope. So it exists in the database as a physical object, and then you can use it as a parameter in the store procedure. So basically, you can say create procedure, and you can declare that as a table type, and they are read-only. So instead of like trying to iterate by like running many times a store procedure, you can just transfer a set of values, and you can potentially avoid iterating or running a procedure multiple times. Or what I've seen is transferring XML like a parameter and trying to shred those data within the store procedure, which is also not good at all. So if I create a store procedure like this, and if I get a table valued parameter, then I can, in another scope, I can just declare table valued parameter, insert those in the list, and then execute. This select statement is just a simple join, and you can see that it's a really simple as a code, and it's a really simple as and really good as a performance. So I mentioned transactions, and they should be short, not too short though, because they will overload the transaction lock with those write locks. But we have to stick to a really good transaction scope. I would say that distributed transactions are not a good idea anyways, not on-premise and not in the cloud either. So I wouldn't go there. When it comes to the code, all-in-one store procedures, so trying to enclose everything in one single logic, you ended up with a procedure like this, but that's also probably not the best coding either for providing a scalability. What's the problem with that? Well, the problem comes when you have to potentially, you can end up with performance in query plan. For example, if you have a branching logic in the procedure, then the first execution will get one plan, which will be reused. But the next time, you can go through a different branch. So that will harm the performance of store procedure. So as they should be modularized in the code, and we should avoid like having complex store procedures in our code. I would say overusage of triggers is something that bothers me as well, and it creates problems when we have to, like, for example, migrate database or analyze performance issues, or they also have a side effect of dominoes in the database, or in increasing the transaction scope so that blocking occurs. How do we use triggers? So how the triggers are used, and what's the pattern which is anti-pattern actually? They are used for two reasons: constraints and history or auditing. Well, if you want to build the constraints, then declarative constraints are way better. They performed way better. They do not start transaction if you break the constraint. So the rollback is not needed actually. So you consume less resources. So wherever you can, it's probably a better idea to use constraints instead of triggers for forcing the database checks. Temporals are used for history. That's a good stuff instead of triggers. And you potentially have heard of, I hope you have heard of Ledger that is coming in SQL Server 2022. So a ledger will guarantee a really good auditing and blockchaining in a database. So that's extremely good option for guaranteeing transactions and that nobody has actually performed a malicious update on your data, even the DBA. Some other stuff here. So you probably have heard about using a global unique identifier as a primary key. Well, global unique identifier is good, but as a primary key, nah. That's because the primary key is also a cluster index in the table. So when you randomly generate data, when you randomly generate values, then that creates a huge fragmentation in the table. And beside that, a page splits will potentially generate a lot of transaction lock. Again, resource-consuming stuff. So that will require you to rebuild indexes quite often. GWT are okay, but not as a cluster index key. So now I'm in the middle of a project for migration and consolidation of banking SQL servers. So we ran a lot of like tools checking the potential compatibility and the potential issues of the existing databases. Some of them are 2012 database coming from even previous version of SQL Server. So we find out that there are still a lot of deprecated features in the database, which definitely have to be removed. What else? Well, I mentioned blocking. When it comes to blocking, there is a specific case, specific reason of blocking, which is when we start from the very beginning of a monolithic design, trying to hold all the data, even for different business processes, for different tenants in one single table. So in that case, every single let's say, update for a tenant data, or like generating a history data and those data staying in the table for a longer time and making table like with a billions of rows. So that pattern is something which prevents you from scaling, and at the same time it tends to create a huge blocking in the database. And that's the point when users try, or DBAs or developers try to find a way to partition, a way to devise data. And that comes partitioning in the database. Well, dividing the data is something that we need to consider at some point, but it's not an easy task anyway. So it could improve the scalability. It could improve storing of large volumes of data. It could improve deletion of the data when the case is a history, accumulating history and deleting old data. Then partitioning could help a lot. But it's, again, splitting, and the level of splitting is not an easy decision, though. So we can start with partitioning. When it comes to partitioning, we have basically something which is native in SQL Server, and we have a function which decides how to perform partitioning. And this function is basically something which will potentially tell SQL Server automatically where to store your data. So the function will split the data, and when you perform an insert, then it will go to the function. The function will return in which partition those data should be aligned and should be stored. And then it should go to the specific file. So what's the most difficult part when implementing partitioning? So I had a session for this last year in SQL Bits, so I'm not repeating that, but it's something that is very crucial. How to partition data? What is the partitioning key, which I will use, basically? So the partitioning key is probably the most difficult part, because if you don't basically run the partition key, if you don't choose the partitioning key correctly, then you will potentially even achieve even worse performance than before. So partitioning key should be presented in every single where clause that you have in the query. Otherwise, it will not be able, SQL Server will not be able to point to a specific partition to get your data. So when it comes to that query, which every single query actually, which you run in the database, then SQL Server on the partition table will assess the where clause and try to isolate in which partition to work, in which partition to get your data. And if it can't, if you don't put that key, then it will scan all the partitions, which, as I mentioned, is even worse. So you can split even longer, so like even on a different level. Like, for example, table, schema, database, server. So basically, depending on the scalability that you have, you can divide your data at different levels. But the problem is, when you divide data by table, like one table per tenant, per client, for example, or one table per month, you have to develop your own function or your own logic for splitting and storing data. And in this case, this could be a little bit more complex. It could go way complex if you implement like sharding, which means every single tenant, like customers' data, go to a different server. So there are a lot of examples out there of how sharding should be implemented, but it could become really complex. So I would potentially increase to that level if there is a need to, if the scale of the business is at that level. Yesterday I heard something like a recommendation during the keynote, I think, that when it comes to sharding, you better use Azure Hyperscale if you are in the cloud with the name tiers. So that could also be an alternative of sharding. So when it comes to partitioning, this is something that we have to consider. And balancing of partitions as well. Well, I mentioned that partitioning is like a good alternative to avoid blocking in those cases. But what about deletion? So let me offer you a hint for deleting from a monolithic table. So what does it mean? When it comes to deletion, probably you learned from experience, which is not very good in most of the cases, because deleting a huge amount of data from the database is extremely expensive from the resource perspective. So instead of like, if you don't have partition, which could be switched out, then you could potentially think about different way of doing deletion to like replacing a delete with something else. So for example, the problem here is in a where clause. If I try to like delete, if the main table is ordered by order date key, then potentially I could end up with a range delete, which is fine. But I have to disable non-cluster indexes. So sometimes, if you cannot afford anything else, just try to disable all non-cluster indexes for performing huge update or delete. Then if the data are ordered by the key, by that column, then you will have range delete, which is relatively fast. And this is another idea. So if I use selecting two to split those two sets into different tables, then I could do anything with those tables. I could potentially go and drop the first table, rename this as a new table, and this will be my new data. The old data could be just truncated. I could insert them back if I cannot like delete these tables. So we basically have several options from there. But as you can see, I don't use delete anyhow. So all those cases, and these hints is basically because in production environment, when you have a big amount of data, you will end up with something like this, and deletion will potentially be really bad. So you can split data based on not just a partition, not just a key, not just a tenant or a month, for example, but you can split data by function. By, like, you can partition one table with the clients for the biggest client, and then you can have other clients in a separate table. So a combination will be fine. In the customers that I mentioned, they had like tenants, many databases in one server, and they had one single database for their biggest customer, and they separated that database on the other server. So you can have many combinations based on the workload. Those are examples that it's worth it to check. All those products actually rely on the tenancy, and they publish a really good stuff on how to split and how to do the sharding part. They all rely on sharding and multi-tenancy design. So there are downtime features, reduced downtime features in the product, which we should consider. For example, online maintenance. Be careful though, because you will increase potentially, again, resources. Yes, you will gain an online maintenance, online index rebuild, but that will be on the cost of space in the transaction log. The same is true for per partition rebuild and asynchronous stats. So asynchronous stats with weighted low priority is extremely useful feature, which could potentially reduce the blocking if you have a lot of compiles and recompiles in your code, and you switched async statistics on in order to reduce the contention. But that contention could potentially happen. So if you see the blocking of the statistics, schema shared versus schema modified as a background process, then this one could do a really good job. in SQL Server 2016, we have online schema changes. So you can alter a column online. For example, change a data type of the column. How many of you know that we have this feature? Yeah, good. So imagine that you use identity. So if you use identity, then and you started with an integer, and you like ended up with an overflow, you have to increase the column size. That will take some time if the table is big, obviously. So there is an option to do it online. But again, the cost is time for that operation and potentially the transaction lock as well during that time. So you may consider that, or alter adding columns with null or with a value. So that could also be an option. Accelerate database recovery is used by all those services that I've shown you here, Azure DevOps and especially Dynamics 365. So extremely useful for long-running transactions and failover. Another anti-pattern which I would like to mention here is trying to store all those types in the database, like XML, JSON, graph, you name it. Well, I would be very, very, how to say, I'll try to rethink if somebody says that it will use the relational database for storing all that stuff, like, for example, XML or JSON. Despite all the new features in the JSON, this is not relational. Anyhow, so remember all those days, old days with XML? XML was really modern. But there were many applications which went to that direction, and they had to rewrite at some point because XML is very expensive on sharding, and it's something that doesn't scale at all. So if you have to use relational, if you have to have your data schematized, then use relational database. If you need a flexible schema, like a database which basically is a store for your application, for the data that comes as the same way from application, then probably you need a different store in that case. So, for example, in that case, we could go to a polyglot persistence. Polyglot persistence is a term which is like polyglot programming. So for every single part, for every single business, let's say, process, which require different data types, we tend to choose a different store. So polyglot persistent means different data storage technologies for different kinds of data. For example, shipping and session data, they are transient data. They are just key and values. So basically, key value store, which is extremely scalable, but very simple, could do the work way better than relational. Then we could store completed order or product catalog in document store. So document store is similar but to key value, but the value, it could be very much complex, and it has the different schema, like, for example, JSON. So every item basically has a different schema. So product catalog is a really good example of like storing data in a document database. So in the relational database, we should have only data which are really relational in order to guarantee the consistency, guarantee the transactional property or ASET, and potentially availability and recovery. If you want to have like a graph database, for example, to serve all those requests, like what are the products that my friends bought or other from that city bought, then that is not a relational question. So that is probably a graph. And we have a REST API, synchronous or event queues, which will be responsible for dealing with the logic. I would say that Cosmos DB now is a flagship offering which could potentially serve all those NoSQL requests or NoSQL data in the database. Microservices is the last trend I would like to mention here because it's very connected to the Polyglot persistent. So Polyglot persistent is like splitting data into different database. Microservices is basically the same, but aligning with the microservice concept from the application perspective. So database per service platform. In this case, though, every single service could have its own database. In that database could be like actually different type of the database. But we have a really important questions to ask here. So what is the scope of a transaction? So when you have a transaction, that transaction should be scoped within a single database. We are not allowed to do a two-phase commit though. And this is something that we should potentially avoid in order to align with this microservices concept. So what is the domain? What is a cross-domain though? For example, in an e-commerce application, that inventory is a single domain, or orders is a different domain, but you can have like payment as a different domain as well. So the granularity is very important. And between the domains, we communicate only with the services. So transaction do not span a domain or do not span a database. So as a review, a takeaway, something that should potentially provoke the process that is going in your side, in your databases, in your environment. Two-phase commit. Don't start developing new features with that because this is very attached to a physical a database and the network and all the stuff and makes the things really complex. But don't go too modern though. So everything should be balanced to the scale of the business. So microservices, Polyglot persistent, sharding, those are concepts which apply to really big enterprises and the big scale. So we can start smaller and we can increase those. But partitioning is something that you could consider in the early stage so that you don't need to redesign your tables later. Avoid those old school practices and go set-based. Get rid of deprecated features because compatibility level matters really. So, and stay relational. Consider NoSQL for other data types. Any questions? Thank you.
Not from the virtual. Any questions? All right,
We have just probably 1-2 minutes for questions.
Yeah.
Yeah.
No questions online.
Okay.
So, any other questions?
So appreciate if you feel the feedback forum. Thank you so much. These are my contacts if you want to send me questions later. And I wish you really good conference until tomorrow. See you again.